All right, so if we have just a regular 3D composite object, okay, we find all the sides and we come up with our final answer. Now, if some context is used in the problem, and context mostly means a word problem, but context can sometimes also mean that there is something outside of just mathematical numbers. It's not just a regular shape. Sometimes there are parts of a 3D shape which are not being found in the area, and you will get questions like this. Okay, so if context is used in a problem, sometimes some thought needs to go into the answer. Not saying that you don't think when you do the questions. Normally, I'm saying that we have to actually determine what parts of our shape or our object are actually going to be a part of our answer. Is the whole thing going to be a part of the answer? Okay, or is part of it going to be actually not part of the answer? The context may inform that one or more sides does not need to be solved for. And this example that we're going to take a look at deals exactly with that. So here's the example. A cake is to be made using two circular levels. Okay, so these are cylinders. You notice they're cylinders. The cake is to be covered in fondant, which is kind of like an icing type thing that goes over top of cakes. For those of you that aren't sure about that, as part of the decoration. How much fondant is needed to cover the cake? Well, this cake right here, if we want to put fondant over the entire cake, we will have to find the surface area for the entire cake. But wait a minute, would we need to put fondant on the bottom of the cake? No. So we only need to put fondant on the parts that are showing except for the bottom. So here we have a circle or a cylinder on top, as well as a cylinder on the bottom, where we need to find the area that needs fondant. Let's take a look at this first cylinder on top here. The first cylinder on top, we need to find the top circle and the outside square, or sorry, outside rectangle. So how we're going to solve for this here, and actually, you know what I'm going to do here is I'm going to put in, I'm going to say this is top. I'm going to put that right on top of there, top of the top, and I'm going to call this one the bottom. So that's how I'm going to label these two pieces. All right, the top. On the top, we have a circle, and then we have the lateral area or that rectangle that goes around. Okay, to find the top, we do pi r squared. And to find the lateral area, that's the circumference. So that's 2 times pi times radius. And then we multiply that by, in this case here, I'm going to call it the height or the length of our cylinder. In this case, it's the height, so I'm going to multiply it by the height. Well, now that we have, okay, I'm going to put that in here as well. Surface area is equal to. So our surface area is equal to pi times the radius. Now the diameter in this case is 14 centimeters, so the radius is 7 centimeters squared. Now remember, when we're doing these calculations, we square the 7, not the pi times 7, we just square the 7. So that's important that we recognize that, important that we use that. 2 times pi times the radius again, which is 7 centimeters, times the height, which in this case here is 5 centimeters. And we're going to get an answer surface area is equal to, okay, so now I'm going to go through and I'm just going to quickly grab the calculator in Google here and take a second to load it up as we're going through. Zoom it in a little bit. All right, so what we're going to do here is we're going to do pi times the diameter, or the radius squared. There you go, squared. Now notice we're only squaring the 7. Okay, we're only squaring the 7. We're not squaring the pi times 7. It's just the 7. And then we're going to do 2 times pi times the radius times the height, which I think we said was 5. And that's going to give us 373.85. Yeah, we'll call it 373.85. So this is 373.85 centimeters squared. All right, that's the surface area of the top. Okay, that's surface area of the top. Now you'll notice with that, we didn't actually calculate the bottom of that top piece, okay, the base, because we don't see it. So we just did one of them. Okay, we just did one of them, and we'll do the same thing on the bottom. Now, the bottom piece, you notice we have this big circle, which has got a diameter of 26 centimeters, but we're going to cut out a small circle. So we actually have to cut out this small circle, the pi times diameter. So in this case here, what we're going to do is, to find the bottom, is we're going to take our big circle, and no, I'm not going to put in the equation, I'm just going to put in pi times the radius, which is 13 centimeters squared. I'll put down the brackets. And then so once we find the area of the big circle, now we need to subtract the small circle. So we're going to subtract pi times 7 centimeters squared. Okay, so we're going to square or we're going to take away the small one. So this is the big one, take away the small one. That's going to find the area of the top. And then we need to add on that bottom piece again. Okay, so that rectangle that goes around the bottom. And so there we're going to have 2 times pi times the radius, which was 13 centimeters. This is now the big one. And then we're going to multiply it by our height, which is 5 centimeters. Typo there. All right, so this one here I'm going to do with my calculator. I'm going to do pi times 13 squared minus pi times 7 squared plus 2 times, made an error here, pi times 13 squared minus pi times 7 squared minus 2 times pi times 13 times 5. And we get 785.40 centimeters squared for the bottom. So the top piece, the surface area of what we can see is 373.85. For the bottom piece here, the surface area that we can see is 785.40 centimeters squared. So our total surface area, and now we'll do this on this side right here. Total surface area of fondant is, we're going to take the 373.85 centimeters squared, and we're going to add the 785.40 centimeters squared, and that is going to equal, we'll do it on the next line there. So we're going to add the two together, 373.85. Now again, I'm using my own calculator here. 1,159.25 centimeters squared. And I will put in comma right there, so it's in the thousands. So this would be the total area of fondant. So 1,159.25 centimeters squared, and that would be how we solve for it. Now you'll notice here that I didn't actually subtract any areas because I didn't add them in. I only already found one top, so I don't have to subtract the bottom. I didn't find the bottom, okay, so I didn't have to subtract it later on. I did have to subtract the area that is cut out. Now, one little thing I do want to point out with a shape like this here that might help some of you to solve this a little bit easier is, let's think about it from the top. Okay, this is what this cake looks like on top. Something like that. Okay, now what you might notice here is we found the area of the top when we did the top cake, and when we did the bottom cake, we actually had to subtract the area of the top circle. Okay, if you look at this, this is all one big circle. This is the bottom circle. If on the top we only found the area of the lateral area, 2 pi r times h, And then on the bottom, we could find the area of the big circle, and that would include this little circle. We could save ourselves a step instead of subtracting. So that is another option as well if you take a notice of it and if you are aware of that calculation. Now, I want you to do questions 2 to 4 on the assignment. Okay, they involve some context to them. Some of them, the context will be that you don't need certain areas. For others of them, you still need all of them, but now there's some context to them. Your context should also have a final answer which has some sort of answer in there. So like here I said total area of the fondant. What you could do as well with your final answer is say the total area of fondant needed was 1,159.25 centimeters squared. And that could be your final answer. You're giving an answer with context for a question that has context as well.